Hello everyone. In this session, I am going to explain you the first phase of our compiler, that is lexical analysis. See, if you want to implement a lexical analyzer, either you can do it by drawing you the finite state diagrams, or else other descriptions that how you can recognize the lexemes for each token, or else what you can do is that you can use the existing softwares, and then you can design an lexical analysis. Okay. The first and foremost step of any lexical analysis is the you have to determine whether the text to be translated is well constructed in terms of the input language. See, what I mean to say here is that you use a existing lexical analyzer generator, or else you write your own lexical analyzer by your hand, that is either with the help of some programming languages, or else you can use the tools like your finite automata, regular expressions and all. But ultimately what it should do, it has to determine whether the text to be translated is well constructed in terms of the input language or not. So what we do is that in this session we begin with uh, lexical analyzer, how to write it, because already we have seen in the lab by using a lex programming language we have written some lexical analysis. So now in this session we will be studying how exactly we can write it by using our regular expressions and as well as finite automata. Okay. Here generally your lexical analysis is going to specify the parts of speech of your program, your language. Okay. So here what it does is that just I have given in the how exactly you are doing it in the natural languages. See here, if you're trying to map the word of speech, words to part of speech, it becomes an idiosyncratic. Mm, and in formal languages it becomes an syntactic. It means that we concentrate more on the syntax. We are not going to concentrate on what exactly that it's going to mean. Semantic is not important here. We are going to make concentrate more on the syntax. So here whenever you are trying to generate the tokens, you must generate in such a way that those are all going to be recognized by the your programming language or the host language. Okay. If you are writing a lexical analysis for C programming, then the C programming language must recognize all those tokens, that how it's going to get it. Okay. So now here these are all the some terminologies that already you have learnt in your automata theory course. Okay. See, for example, an alphabet is going to be defined as a set of symbols. See, why you need to know all these definitions means, here when you are going to process the your input, you must know what are the alphabets, what are the rules, what are the strings, what are the languages and all. So that's what a simple definitions are given here. An alphabet is a finite set of symbols. A string is a finite sequence of symbols from a vocabulary. It means that, see, this is going to be vocabulary in the sense means that respective programming language, or for whichever language you are going to define concern to that, you must be able to get some finite sequence of symbols, and that is going to be treated as string. A language is any set of strings over a fixed vocabulary. Already we have seen the you will be creating some strings based on the alphabet set, and those are all going to be acceptable in the language. And another important thing, we have already studied a context-free grammar or a grammar. It's going to describe the language. And we have seen the definition of a grammar is it's going to be of four tuple, that is it consists of states, that is you can it consists of a starting symbol, then it has got some non-terminal symbols and terminal symbol, and then it has got some rules which are going to define your respective programming language. Okay, so the language is set of all the terminals of the respective grammar. Okay, these are all the some terminologies, but we are interested more in the lexical analysis. I concentrate more on that. Before that, why you have to study the lexical analysis? These are the simple things. Because see, you must know, whenever you are studying about the compiler, the compiler initially it takes a input which is there in the some source language, generally in the high level language, and it's going to produce the a target code. Okay, here you have to study the your lexical analysis, because that is the that is where you are going to create the tokens. Okay, so now you must be able to write some this thing, how the scanners are going to work, isn't it? So what we are going to do is that to avoid the writing lexical analyzers by hand, it means that you your the main intention is that you have to create the tokens, and you will be writing here how to create the tokens. And when you are going to use the lexical analysis, uh, it is, see, suppose if it is if it is combined with the syntax analysis, then it could be difficult to design, or it is difficult to specify what you are trying to do. That's what in the lexical analysis what they do is that you can specify the all the specifications and implications you can do, you can simplify. That is to simplify specifications and implementation, and to understand the underlying techniques and technologies. Say why you have to study another lexical analysis means you must know how the compiler is going to process your input, and it converts into tokens. What are the techniques underlying in that? That's what you should study. So here, why you have to study the lexical analysis means the three important reasons here: to avoid the writing a lexical analyzer by hand, to simplify the specification and implements, and to understand the underlying techniques. Okay, now here, whenever you are writing an lexical analysis, you have to give the patterns. So those are called it as lexical patterns. Generally these lexical patterns are going to be defined or are going to be specified by using a regular expressions or your finite automata. Okay, we'll see one by one in the coming session. So now here, when you are going to use this, uh, um, some the what generally your lexicon analyzer it does that, it's going to remove some white spaces, because one white space it takes the consecutive white spaces are going to be eliminated, or it's going to be it's not going to consider all those white spaces, and it must be able to differentiate which are all the keywords, operators and all, and then it must be able to eliminate the comments also. And sometimes see, this is generally when it is going to recognize the tokens, identifying the words, your keywords or operators or white spaces, then it is easier for the lexical analyzer. But the same thing is not possible when it's going to work with some complex things like identifiers and numbers. That time it's going to be a little bit trickier than trickier for for a lexical analyzer to do that. Okay, so now we will concentrate more on how it can be done. Okay, so now here, what is the role of your lexical analyzer? Just understand here, uh, the main, as I told now, the main task of the lexical analyzer is to read the input characters from the source program, and it has to combine them into a lexeme. It has to group them, means read the input characters and it has to group them as a lexemes, and it has to produce as a sequence of tokens for each lexeme in source program. See, for understand here what it is doing, first thing it is reading the input from the source program, that is the first thing. Then it has to group them as a lexemes, and then match these lexemes for a tokens for which it is applicable. Okay, so this is the major task of the your um, lexical analyzer. Now understand here, as shown in the diagram, you can means it's a, you can easily understand here. The first phase is lexical analyzer. For that you are providing a source program. Now what it does is that, see, the outcome of the lexical analyzer is to generate the tokens. Now these tokens are fed as an input to the parser. So here what happens, whichever the tokens it is going to recognize, and which is going to recognize, will be given as an input to the parser. Now the parser will do its job according to the grammar which is given. Sometimes what happens here, if the parser requires some tokens, then it simply calls a function called as get next token. So it means that the parser is in need of some tokens, that's what it is asking the lexical analyzer. Now understand here, whenever your lexical analyzer recognizes that it is an identifier, then it has to store it in a symbol table. See, this symbols table is going to be constructed when your lexical analyzer is going to recognize some of the lexemes as identifiers. So what it does, it's going to store these identifiers along with its location, means where they are going to be stored. Sometimes it is going to be stored with your attributes, identifier and attributes. So that's a pair. We'll see that later, but just understand this diagram, how the lexical analyzer is going to generate the tokens, and then it supplies to one parser, and the parser is going to utilize it for its purpose. If it requires anything, then it is going to call back the lexical analyzer. So this is what a communication between the lexical analyzer and the syntax analyzer, or you can say parser, takes place. Okay, so the symbol table is going to be used in both the cases. If the lexical analyzer, once it is created its symbol, it recognizes as an identifier, it stores it in the symbol table. The output of the parser is here, is given to the next stage. So the some important task you can understand here. Whenever we'll be focusing more on the lexical analyzer, just let us briefly list the tasks the lexical analyzer is performing. What the lexical analyzer is doing, it's going to generate the tokens. That is the first thing. And then what it does, it's going to strip out all the comments and white spaces. Strip out the comment means if you are providing a multiple spaces, then all those spaces are going to be stripped out. Okay, and then it's going to remove the comments also, because comments are not a it's a just a user informative statements. So those comments are also going to be removed by, or they are not going to be considered by the your lexical analyzer. And along with that, the your lexical analyzer has to perform another important task, is that it has to whenever it is performing any task, or whenever it is generating a tokens, if it recognizes that there are any something which cannot be matched, or something which is not there, at that time it can produce an error messages. So here it is, if the lexical analyzer, if it realizes that it's not an proper character of that respective language, then it can create an error messages. in case of C language, suppose if there is some space, some character is there, and that character is not at all valid in that C programming language, then it can create that it is a lexical analyzer. Means it can create an error message. So now the your lexical analyzer is going to perform all these functions. Okay. So now just a small example is taken here. You can just check it out here. uh, Here, if the input is given something like this, y is equal to 31 plus 28 into x. Now if this is given as an input to the lexical analyzer, now understand here how the lexical analyzer is going to create a how it's going to process. See, initially y is there, it after that y immediately assignment statement is there, so it treats that it's an identifier, and that value of that identifier is y. It means it's an attribute. You should understand here why this attribute is required, because in your programming your lexer is treat that it is an identifier, but which identifier it should be. So that's what it does. It has, whenever it is storing an identifier in the symbol table, it always stores along with its attribute value. After that, you can see here there is an assignment statement is there. The second column is the attribute is not there for an operator. Then next is 31, it's a number, and 31. See again here, the num is an a kind of an token, and the 31 is the lexeme which is matched for that number. Okay. Then plus is again a lexeme, it is matched for some operator. It does not have any attributes. Then again number 28, then multiplication, and then finally it is idx. See now here, see in the while storing it in the symbol table, if it stores only the id, then which id it should refer, that's what it always need an attribute there. So now all this here, you can see it here, we have means here we have written the here it is, um, you can just observe it here. We have written the id as token. It means that okay, that's the token name, and then the its attribute value is y. Similarly here it is id comma x. So now this will be given as an input to the parser. This is a just small example of how the your lexer is going to create. We will be studying this in detail, how exactly what are the techniques that lexer is using to convert this stream of inputs into a respective tokens. Now see in this, if you consider this example or here, is it necessary to have two different phases? Of course it is necessary, because if both lexical and syntax phases are together is there, means there is the complexity lies. So if they are separate, then what you can do, you can whatever the modifications if you want to do for an lexical analysis, you can do it separately without affecting the syntax analysis. So hence the if they are together, if they are separate, then simply you can design with a in a easiest way. And when you are since the syntax analysis is a very complicated task, if you combine together, then it may take a lot amount of time, and it may take more space also. That is means, if the lexical analyzer is separate, then the syntax analyzers are separate, you can improve the efficiency of the compiler. And similarly, when you can there is a another part is that you can use compiler portability, it is enhanced. So what you can do is that you can restrict your what are all the what kind of an input it has to take, and how it can proceed. Like that you can provide some kind of an portability in uh, um, lexical analysis if it is designed separately. You can just see the we were talking about the terminology like token, pattern, lexeme. What exactly it means that uh, a token is a classification of lexical unit. So it means that you consider any atomic unit of your language for which you are referring, so that those are all called it as tokens. So in this case the example is id, identifier, and then if any number you are taking the number, so those are going to become your tokens, like operators, plus, minus, multiplication. These are all some arithmetic operators. Like anything you can take, that is the most atomic unit of that respective languages. Then comes the lexemes. See, another thing is that whenever you are creating a tokens, what you should do is that you have to uh, generate a token along with always a pair. That is, what is the name of a token and its attribute, as it is shown here. You can see the id comma y, where id is a token and then its attribute. See, this attribute can be an optional, because in case of an assignment operator we don't have any attribute value. So it is always better to create a tokens in a pair, that is a token name and along with an attribute, optional attribute value. Okay, the next definition here, it is lexeme. Lexemes are the specific character strings that make up a token. See, your lexical analyzer is going to take a input of it's going to take a some input characters, or you can say some stream of characters, and then whenever it reads a one character, then it will try to match to the language tokens. Either it could be a keyword, or it could be any your identifier, or it could be any your operators, like that. Whenever it matches to that, then it will create a that type of token. So here the lexemes are the specific characteristics that make up a token. So now see, for example, here abc is taken. See, when it realizes that when it reads the character a, it's fine, it's an alphabet, then it reads the next b, then next c. After c, if there is a space is there, immediately it realizes that it could be an identifier, because we have defined the what is the meaning of identifier. Similarly, when it gets to the 1 2 3 like that, then it treats that it's a number. Again, which type of number, whether it's an integer number or real number, that's a separate issue. But when it reads those inputs, then it's going to realize that it's a number. So lexemes are the specific characteristics that make up a certain token. Okay, next comes the pattern. The patterns are rules describing the set of lexemes belonging to a token. So now, as I told that if you want to create an identifier, if you want to identify that it's an identifier token, then you have to give a pattern for an recognizing the identifier. See, generally in identifier we say that letter followed by a letter or digit, so that's the pattern you are given. So like that, the patterns are going to be considered. These are the simple definitions that you can just see. Now let me take an example here. For example, here we have taken the printf statement, which is the C language statement. Here you can see that when you give this as an input to your lexical analyzer, the lexical analyzer must be able to mm, identify these lexemes. First, it should recognize that there is a certain lexeme is there, then it has to match a particular lexeme to a what kind of tokens it's going to create. Okay, so now in this case, in this example, the printf and score. See, these are the two things which will match for an token identifier, printf and score. The uh, the string within given in the double quote, here I forgot to give the double quote at the after this new line. Sorry for that, it's not a one, it's an double quote. Okay, printf. See, the total equal to percent t slash n, then double quote. That's a, it's going to recognize that it's a literal, because in C language whatever you enclose within a double quote, it's called as literal. So in this example, your lexical analyzer must be able to uh, identify, or it must be able to create a three tokens, that is printf, score as identifiers, total equal to percent d till this double quote ends, it says as a literal, and then the opening parenthesis and closing parenthesis, and then semicolon. So it must be able to create a tokens like that. Okay. Then you can see it here some more examples, um, how it can convert the this thing. See, when it wants to recognize the token if, see here it is, the if is a keyword. So what your lexical analyzer does is that whenever it is going to when it recognizes the first I, then it will check the next if, then after that if space is there, then it realizes the lexeme identifier till that point is if, then it recognize it's going to return it, it's an a token of a keyword, that is if. Similarly for an else, similarly for any arithmetic of any comparison operators, like that. And then identifier, we have seen that letter followed by a letter, it treats that it is an some exam. See, for an identifier, the your lexeme could be something called pi, score, d2. It means that anything which begins with an alphabet followed by a letter or digit, and then that all will be considered as an identifier. So if you take only number, then here it is any numerical constant you can take. Either it could be an real integer, sorry, it's a real number, or it's an integer number, anything it could be. Okay. And when it is treating that it is an literal, then it must be enclosed within a double quote. Okay. So these are all the few examples that how your lexical analyzer is going to create. See, now the same thing what I have explained now, if you want to do it by using your own, if you want to code for it, then what you can do is that you can write something like this. Just focus on the function here, something like that, how the your lexer is going to request, your parser is going to request for an next token. So that just a small snippet of the code is written it here. It would be something like this: get next open. So now here you have to read the first character, and whenever you read, you check it out whether it's an end of the file. If it is an end of the file, then you just close, you have to return it by closing that. If it is not a end of the file, then what it is. And since it is an, if you're see, this example is given for an identifier. So when it is going to recognize for an identifier, then you have to check whether if it is a digit. If it is a digit, see, I am going to read a character. If it is a letter, I can start it with an recognizing an identifier. If it is a number, then directly I can go it for a number. So it means that your whenever it reads the character, for each character it has got its own function. So now just see here, if is letter C, then immediately we are calling a function called as recognize ID. It means that we can think that it could be an identifier. But see, it is not necessary that it should be an identifier, it can be even a keyword also. Okay. Like that. But just an example here, if it is not a letter, then check for a digit. Yes, if it is a digit, then it could be a some number, it could be an integer number or real number, like that. If it is not, then if it is not a letter or if it is not a digit, then you check it out, is there any operator which you have mentioned as your arithmetic, or any bitwise operator, logical operator, like that, or any operator which has got some meaning in the in your programming language. So then you go to that respective programming language. If nothing else is there, then you call the error message, isn't it? So that is what how your the process of identifying the token begins. Okay. Now just as I was telling you that whenever you are whenever you create a tokens, then you should have always an attributes for that. The meaning here, when you provide an attribute, so these attributes are very important because they influence the parsing decisions. So generally, if you don't provide a token without an attribute, then the parser may take some wrong decisions. So these attributes are going to influence your parser. So that's what the attributes are very important. Another thing is that if you simply recognize that it is identifier, which identifier it should be. Take an example here, which is given, which is a problem statement in Fortran language. In this Fortran language, your identifier are going to be same as of your C programming language, but here you see here E is equal to M into C. If two consecutive star marks are there, means it's an exponential. So then how your Fortran compiler must able to differentiate. The first one is ID. Then see here E is there, E is an identifier, it's fine. But if you write it as just an ID, then which ID it should be? So if you write just, if you say that it is a just ID, it's going to be meaningless. That's what you have to do, you have to use an attributes. So now here what it is, when you are, for every identifier you will be making an entry into the symbol table. So now what you have to do is that you have to provide a pointer to symbol entry for an E, that is first identifier. Then assignment operator is there. See now again you get an identifier. So now again you have to provide an, what is the uh, address of the that M in the symbol table, that is pointer to symbol table entry. So like that if you do, then your Fortran compiler must be able to create a tokens like this. Totally how many tokens? 1 2 3 4 5 6 7 tokens it has, and all are listed here. See sometimes what happens, these attributes are optional, as in the case of assignment operator, multiplication operator, exponential operator, here the attribute is optional, but it is always better to provide an attribute wherever it is required. Now another thing here, understand here now what exactly happens in the Fortran language only. So now you take the first consider, that is do phi I equal to 1.25. What exactly you mean by this? See now sometimes what happens, see it is begin with a do. Suppose if your Fortran compiler suppressed the white spaces, then what it's going to become, do phi I continuously it becomes equal to 1.25. So it thinks that it is an it's an a assignment statement, correct? Now see the second part here, do phi I is equal to 1 comma 25. So now in this case what happens, see in the here the same thing is there, do phi I equal to, when it thinks that 1 comma 25. See after here earlier in the earlier statement it is 1.25, then it can be treated as number. But when it here in this case 1 comma 25, immediately your Fortran understand that it is a looping statement. So this is what the importance of providing an attributes in case. Okay, so now when you are providing these attributes, there is a possibility that something you have a the possibility of getting an errors. Then how the lexical analyzer is going to handle these errors? See consider the first statement which is given here, fi. Assume that it is a C programming language statement. Okay, now here when you give the fi, what is it, an error or it's an statement? Now what the your lexical analyzer thinks that you might be thinking that this is a if statement. Of course for you it is a if statement, but for what the lexical analyzer thinks that when it matches the f and I, it thinks that it could be an identifier, because it is satisfying the rules of identifier. So it treats that it is fi is an some identifier, and then after that a is equal to f of x. So in this case, in fact you are writing a C program with a condition statement, that is if. Typographically you have done a mistake that it is a fi, but the lexical analyzer is not going to create any error for this. It is absolutely right for an lexical analyzer to generate this as an identifier. It's a token as an identifier. You might have misspelled it, but the lexical analyzer is not going to declare any error here. Now what happens is that okay, if sometimes if you are creating an error like this, whether the lexical analyzer has to stop processing further or it has to continue. That's what you need to do, is that you have to apply some error recovery strategies. So here if I consider already the The error recovery strategies topic is given as an assignment. I hope you might have studied that. If not, you please go to the uh, respective subtopic, and then you please study the all the error recovery strategies. So in that one, the simplest strategy that you can use it as a panic mode recovery. Now what you can do is that whenever if your lexical analyzer is unable to classify the lexeme into a respective token, then it can apply some error strategies, some possible error recovery options it can measure. The first thing is that it can delete one character from the remaining input. So what does it mean? It has processed something, and some lexeme it is identified, but this lexeme is nowhere matching of your all the language constructs. Then what you can do, it can remove some characters so that it tries to match for the any of the tokens for the remaining input, isn't it? That could be one thing. Or else it can insert a missing character into the remaining input. Suppose if you have missed something, in case if you are writing, when you are writing an int, if you have missed an t, then something like that you can do, whether it is by inserting those particular character, then it will be able to recognize that it's a token, and it continues with an execution. Or else it can replace a character by another character. So that possibility is also there. See, these are all the panic mode recovery strategies. Something very simple and easier to that, so that the lexical analyzer, what it can do, instead of stopping your execution whenever it encounters an error, it can do some kind of an manipulation to that input, and then process with a thing. Anyway, when it goes to the parser, that is when the syntax analyzer is going to process these inputs, that time it may it may generate an error reports, as in this case of f5. Here what happens, your lexical analyzer thinks that it is FI is an identifier, and then it continues. But what happens when it goes to the syntax analyzer, then syntax analyzer thinks that it should be an error, because it's not an FI, it's not an identifier here, it should be a keyword. Like that, there is another error recovery strategy. You can use transpose to adjacent characters. So by doing the transposition of the transpose of the two adjacent characters, you can change those places, and then you can think of it as in the case of fi, it can be done it as if. In such a case also, what it can do, your lexical analyzer itself can do those things, and then it can continue. So now in this session, what I did is that I have just explained you what is the why the lexic what is a lexical analysis, why it does, and how the lexer and parser communicates internally. Then why the attributes are very much essential, because if you are recognizing in tokens and without an attribute, that time it's very difficult for an parser to apply a rules on those tokens. Okay. Then we have seen the lexical analyzers versus parsing. Then I just gave an simple definitions for the tokens and pattern and lexeme. And then we have seen some tokens here, and then this is just a small code how you can design a get next token function. Then the attributes are very essential for all the tokens, to store it in the symbol table or to get and for a parsers. And how you can manage the lexical if there are any errors with the lexical analyzer, and then how you can proceed with the further part. So now this is the beginning of the lexical analysis, and in the next class I will be explaining what are the techniques that lexical analyzer can use to classify them as a tokens. I hope you have understood all the concepts which are explained here. So please go to the means you refer the compiler textbook, a 3.1 subtopic. If you have any difficulties in this, you can mail me, or else you can give me a call also. I am going to conclude the class here. Take care, stay safe.